Sometimes I catch myself wondering why people don't separate state and behavior in their classes. What's up, YouTube? In today's video, we're going to be talking about state and behavior and separating these in your classes. So when you design or define classes, I design classes in such a way that I separate out state and behavior. So what does that mean and why would I do that? So this is one of my Let's Talk series, which means there's some sort of a controversy between those who do and those who don't. And I'm all for it, which is why this title says, yes, please, for a change. All the other titles so far have said, no, thank you. However, I've flipped the question, which is why I can say, yes, please. So because I know most people see objects as these real life objects. So if you have a vehicle, then not only does it have some attributes or certain state, like number of wheels, the number of cylinders, etc., make, model, year, but also behavior, start, accelerate, brake, turn, all these kind of things. People see or are trying to mimic these real world objects and sort of, I think, in many ways pretend. And now let me also just preface this whole thing by saying that I've done this. I've been there. Most times when I'm against something, it's because I've been there. I've done it. I've experienced it. And I've been reformed since then. So you will never find me talk about something or trash something that I've not done myself. Okay, I don't just read about things. I don't just play around for 2 minutes and kind of come to a conclusion. I have lived the experience. Okay, everything I talk to you about on this channel is a lived experience, is an actual, honest experience. I may go towards that experience or away from that experience, depending on what the outcome is, over sometimes many years of following a certain practice. This practice of trying to mimic or model classes like real world objects, I have done that from the get-go, from the my beginnings of my object-oriented programming kind of career, and especially when I started to understand object-oriented programming even more than initially. I was kind of just tripping over myself and kind of getting stuff working. At some point in time, maybe 3-4 years into my career, I started to actually design object-oriented systems. I was very, very proud of these systems, because who wouldn't? These were pure object-oriented systems. These were exactly modeled like a purist or designer would do it. I mean, I am not in the mode of wanting to compromise in most things in my life. So when it comes to my work, it's the same. I do things the way I can perfect it or achieve it. I may not even get there, but at least I keep trying to get there. So these systems were extremely OO-ish. Okay, nobody could find fault. An object-oriented programmer could never find fault with these designs. They were probably over the top. Some would call them over-engineered. So I have a different take on that these days. But what I'm trying to get at is, I've been there. I've done it. I had bought into it. And very quickly, I realized, well, not very quickly, depending on your frame of context. I've been doing this for 25 years, so very quickly it could be, 5 years, right? Over a period of time, from feedback from people on the team, having my own thoughts about stuff as I'm building out these systems, starting out new ones, certain things came to my realization. And of course, it was, as is normal, we don't like to hear certain things, especially when it comes from other people. But even in my case, I am finding certain problems with these systems and I'm refusing to accept them to be problems. I would chalk it down to things like, man, we just need to get with this shit. You're just too stupid to understand what's going on. It's too big a system at this point. So, give yourself some space. You're going to take time to figure this out, because I'm not the only one writing code in the system. There's a whole team there. And so the code is growing in leaps and bounds. And everyone is silently or sometimes vocally complaining about the clutter of classes, the unable to understand what is going on in the system, unmaintainable. I mean, everyone's proud. You look at the code in chunks, it's, oh my gosh, these things are so beautifully designed, right? You got classes, they got state, meaning attributes or properties that maintain state for every object, every instance. Behavior, so an order can go create itself, an order can go delete itself, and oh my gosh, it looks so cool. But over a period of time, at least the way I was going down that path was, okay, like, it's fine. There's the academic way of doing things. And then there's the real world. Okay. And in my past career, electronics, it was the same thing, right? In academia, you are taught certain things, there's all this theory and all the practicals. In the real world, man, you are in a totally different planet. You are not doing anything like you thought you were going to be doing when you were in school. The understanding and learning you get by actually doing something is vastly different from the theory that the knowledge as I call it, you could learn by reading a book, being in college, online. So there's a difference between information, which is what you can get on Google, which you can get from my videos, by the way. It's information. For you to convert that information to knowledge, you have to have had some experience. You've got to take what I'm saying and you got to try it out for yourselves to understand that information, which means now you're starting to get the knowledge from that information. Just reading or listening to me or reading of somebody's blog or reading a book doesn't give you the knowledge. It gives you the information. You have to convert that information to knowledge by some form of practical conversion. Maybe you take the same information and you dice it in 10 different ways to understand, to confirm your understanding. If it was like this, and would I get there? Was it like that? And if I get there, so you're playing these games in your head, playing through different permutations. Or in the case of programming, you actually write some code and you use different technologies to try and achieve the same thing, whatever I'm saying now, to convert or translate that information to knowledge. Knowledge exercised over a period of time gives you experience. And that takes a long time, many, many years, decades sometimes. So using that knowledge over and over again gives you experience. And once you've done or got that much of experience, like, decades of experience, you tend to become skilled at that thing. Now, a skill is like the epitome, is the top of the sort of the chain, meaning you don't get better than the skill. Of course, you can get better and better at your skill, but what I'm saying is that's where you want to be. There's a problem with being skilled. It's like, if you don't know how to ice skate and you go and talk to, the Olympic champion, he or she's going to say, well, it's easy. Really. You haven't a clue what it takes, right? There's no way in hell you're going to get up and put those skates on and just fly through the skating ring and start doing all the twirls and the twists and everything else like they do. They have attained a skill. By the time you attain a skill, that complexity disappears. It's automatic. You're on autopilot. So what I'm getting at, I'll touch back on this. So basically, I was just wanting to bring out the knowledge, experience, and skill. There are different levels it takes decades and decades, each of these. But information is not knowledge. You have to convert this information that I'm giving you to knowledge by actually doing or playing with something and trying out different experiments. Okay, and then you get the knowledge. Then you understand what I'm saying. And then you do that many times, you get the experience. And then you do that many more decades and you get skilled at that thing. Okay, so just go back. I'm going back now to, sorry, I deviated here. So I was in a place where what I was doing made a lot of sense to me. Why? Because I built the thing. I designed the system. Most of the classes were done by me. Most of my team were filling in the blanks, if you will, in the implementations of things. But I decided what class, what name, what method, what arguments, all of that. And so it was making a lot more sense to me than it was making sense to the team. That was one problem. The second problem was when you're debugging, or just if you're new to the team, to wrap your head around what is going on in the system and who is doing what is a pain in the ass. I was going to say backside, but I'd rather just say pain in the ass. Because it is. Now, when I put myself in their shoes, when I was putting myself from their point of view, a new person joining the team or somebody who's not been in the team long enough and trying to digest that system that I had been designing or those systems, I had to accept that these are overly effing complex systems. And our primary job in software engineering is to simplicate, not complicate. Get it? Simplicate, not complicate. And there's no reason to it. That's what our job is. What we tend to do is we complicate, which is we take things that are fairly simple and make them even more complex, like I used to do when I used to design my perfectly object-oriented systems. I take a simple problem and I design this beautiful system, object-oriented, pure object-oriented system. And now it's overly complex. To make simple is not easy. You might have heard me say that many times in the other videos. Simple is not easy. And that has two meanings. One is it is not easy to make something simple. All right. But simple and easy are not the same thing. So going back to the ice skating example, and you take any skill, and whatever it is, I've worked with people who are machinists. They're working on these lathe machines, doing stuff with steel and metals. And this one guy visually could, shave off a thou, a thousandth of an inch. That's a thou. I didn't believe it, so I had to measure it. And it was a thou less than it was before. Now, that guy had been doing it for 50 years. So he knows what he's saying. I was like just watching and said, no way in hell you would know that. How could you didn't even measure the damn thing. There's no way you could tell me that's a thou. He said, that's a thou. Anyway. Complexity becomes easier as your skill level increases. The complexity doesn't disappear. Just because I can do something that is complex with my eyes closed doesn't make it that it's not complex. It's become easy, but it's still complex. For you, the same complexity will not only be complex, it'll also be difficult. So easy and difficult are the opposites, and complex and simple are the opposites. So for me, something can be complex, but easy. I can't hide the fact that it's complex. I mean, ice skating and twirling around and jumping up in the air with 3, twists and landing on your foot and not falling. You can't tell me that's not complex. That is complex, but it's easy. They've done it so many times. They've practiced. They got the skill. They can do it. For them, it is easy. For us, it is difficult. So the problem is that when you do something for yourself, design the system for yourself, that complexity seems to be, at least to you, maybe you're fooling yourself like I was, is also easy. But if you were being honest, you realize maybe you don't think it's really, difficult. But what if you thought of different ways to do it? Which is what I did. Right? And I said, well, there has to be another way to do this. It can't be so difficult. Right? These are simple systems. I mean, the problem we're trying to solve is simple. The solution is complicated. So we need to be simplicating. And so this talk is about that. There are a few things that make our software object-oriented programming software complex, unnecessarily complex. Okay, one of them, the key parts, is combining state and behavior. So what is state and what is behavior? Behavior are methods. Right? So in objects, there are methods, that's behavior. State is typically properties, private members, any way of maintaining state, any way of maintaining information in an instance of a class, and that information then sort of stays around until the class disappears. So you can share that information with that class, with other classes. Other classes can share information. You can access property values from that instance. In my systems, for many, many years now, over a decade or so, maybe more, actually quite a bit more, I've been separating out state from behavior, which means my DTOs, I call them, data transfer objects, or some people call them value objects. They are immutable, unless you go to immutable classes. Basically, the idea is that once you create an instance of it, you cannot change any properties. So you have to set all the properties it has at the time of construction. And from that point forward, you can't change the properties. Okay, so for example, here's an immutable DTO. Okay, so it's obviously sealed. It doesn't descend from anything. It's got these properties, but they're all get-only properties. And of course, this is the new syntax for C# 7, I think, where you get behind the scenes, there's a backing field that is defined as read-only. So you're almost forced into the fact that you have to set this title in. It has to be set in the constructor. It can't be set somewhere else by some other method. So there's only a get, but in the constructor, it'll be allowed to be set. All right. So this is an immutable DTO. So I have DTOs that are immutable. And these are the classes that sort of move around. These are classes that are passed around in your system. They have no behavior and they cannot be modified. Why would you want to do that? Because it's easier to wrap your head around. It's easier to comprehend your system when the stuff that's moving around is harmless. It can't change state. It can't do anything. It's like me giving you a key to a vault, but the key is like a blank. It can't do anything. You still have the key, except you can't use it for anything because it's not going to open anything, right? That safety, the guarantee that you have when things are moving around in your system, the information is available, yet cannot be modified. And those things, because we have an instance of that class at hand, you cannot call methods on it to do some weird thing, like save itself in a database or delete itself and all this sort of thing. So immutable or DTOs are immutable. So that's one kind of class. There are actually 3 kinds of classes. Today we're going to talk about 2. The third kind is statics. So this is going to be a talk after this one, most likely called Let's Talk. Static classes, I'm going to say, yes, please. Exactly. Why? That's another can of worms. So I'm going to talk about that in the next video. Okay, so but moving back to this DTOs, immutable. So they are DTOs, they're stateful classes, but they're immutable. So they get once you have an instance of it, its state cannot be modified. So even though it maintains state, the state is unchanging, which in itself has the benefit, as I said, nothing can be done to it. It's not magically going to transform itself as it moves around your system. That allows you to reason about your system in a much better, easier. It just makes it easier. The second kind of classes are those that have behavior but no state. So these are classes that do things but have no state. Now, some people relate statelessness or statefulness to properties, which is to some extent true. I'm going to show you a class. I'm going to explain to you why, even though this class has properties, it is stateless. Okay. So I want to qualify what I'm calling stateless. Just to be clear, it is stateless for all intents and purposes. It's stateless. I just want to make sure people understand that you can't just correlate properties to mean statefulness and no properties to mean statelessness. Right? So, but I'll show you that class. But these classes are stateless and they do behavior. They may get these DTOs, the other types of classes, the immutable stateful classes, as arguments, or may return them as part of their return types in their methods. But that's it. There's no movement of behavior classes in your system. You don't pass a behavior class to another class that's also a behavior class. That's like, like some people who design this, and I see this all the time, where the order class and the customer class, okay, who gets what? Do you get the customer to create the order, or do you give the order to the customer? Like, and they have these classes that are beautifully designed. They've got attributes and they got behavior. And you say, okay, I'm going to send the order to the customer. I'm going to send the customer the order. And then the order class will call a method on the customer to go say, it is very difficult to understand, very difficult to reason about your code when you pass classes around that have behavior, because you don't know who or where is going to call what method on it. Imagine you're on a team, in a software team, and each of us has certain work to do in this sprint. The team lead, or whatever, the scrum master, is for the most part confident that you will do your part, I'll do my part, somebody else will do their part. Very clear cut, right? And at the end of the sprint, it should all kind of merge in and fit together. But if I did your part and you did somebody else's part, and somebody else did my part, and I'm also doing 10 other people's part, and they're also doing the same things, that's going to be chaos. The team lead or the scrum master is not going to understand what the heck is going on in this team. Like, who's doing what? Because it's just impossible. That's what happens when you mix behavior with state. And because if you're passing these classes around, these behavior classes around to methods, it's impossible to understand who's calling what method on the class, right? So at a high level, that's what it is. Behavior are classes that have methods, but no state. Doesn't mean no properties. So I'll show you the other class I was talking about here. Here's this class. I call this is movie manager. It's a behavior class. It has properties, and it's got some private members here. So you can see these are all properties, right? And you're going to say, well, then Shiv, this thing has got properties. How come it's stateless? Why do you consider this to be stateless? Because the state that it does have are nothing but references to other classes that are also stateless. By that, I mean here, look, if you look at this. These are instances or references to other classes. These classes themselves are stateless. The same thing over here. It's a reference to another behavior class, but it's a reference, but that behavior class is also a stateless class. And therefore, this class, even though it has properties or members that reference other classes, they themselves don't have properties I can call. See, these properties are all private. So it's not like you can access the properties of this thing outside. So just because you may have a reference to this thing here, you can't call the properties, right? So you can't manipulate the state directly. These classes, behavior classes, are used internally by this class, but they're not passed around. There's no methods that have behavior classes. That's the DTO, or the immutable stateful class. And these are all also this. That's it. There's no. You don't pass these behavior classes around. You may use them in a composite, like over here. This class, which is a behavior class in itself, is using other classes that are also providing it some functionality, some behavior. They are themselves stateless. These private properties are private. Properties are private. So you cannot access these properties even if you have a reference to this. But you can call methods. As far as you're concerned, this class is a behavior only class. The properties it has, even though it's maintaining state, is simply maintaining a reference to other classes that are also stateless, and they don't have any properties either. So you can only call methods on those classes and so on. Okay? So what I found, once I started to do this, it took me a while, like a couple of years to sort of fine tune this. But right away, not only did I feel this thing, but everyone on the team that had been working with me in the past would start to say, oh my gosh, why are these systems they're so simple, isn't it? It's like so easy to understand, like what's going on and what's happening and who's doing what, like which class is doing what. And I said, yeah, don't you think? And they said, yeah, it's like pretty simple. Now, a few things happened here. One is the number of classes were cut down. That was the other problem I found, was when you try and model the real world and you have this whole single responsibility bullshit, I'm sorry. Single responsibility is a thing, yes. It's a thing when you have problems. It's not a thing when you don't have problems. Okay, and Uncle Bob will tell you that too. I think most people have misunderstood what he's been saying, because he's not been very clear, right? It's only when people sort of push him for an answer that's when he will kind of say, well, you only do that, when you have problems. You don't do it from the get-go. You don't start off building a system using solid principles. It's when it comes time to doing some sort of refactor. That's the time you need to apply these techniques. Okay, but not now. Anyway, I'm not modeling the real world. For me, there's no real world when it comes to a software trying to model a business requirement. What I'm modeling is the business requirement. Okay, so for me, an order is not a smart thing. It's an order. It's a piece of paper that has information on it. That's it. It's a DTO. It's an immutable DTO. That's an order. It can't go save itself. It can't go copy itself. It can't go delete itself. It can't go whatever. It doesn't. There may be some other person, some other thing, some other class, like this way, in this case, this movie manager you saw. It is the thing that operates on that DTO. Let's say the order. Let's say there's a customer manager. The problem with the mix of behavior and state is that there are many times in a real world system. Let's say, for example, you have a department. A department is not just working with one thing, right? It's working with multiple things, multiple entities, which are like these smart objects, order, customer, this, that. But the operations or the functions are across entities. And you conveniently, the purist will conveniently pass one object into another as if that's how it's supposed to happen, right? No. But if you get it in the real world, in the real world, not in the fake real world, these people in the department are working with customers and orders, let's say, and they are operating on the data. Right? They don't tell the customer to do something. They get the information from the customer, they create an order, and they process the order to make it a thing, like a real thing. So if you were to look at it from that point of view, there is a thing, like as let's say a department, that manages multiple entities such as customers and orders and performs some functions on them, right? It's not that the customer itself is smart or the order itself is able to do its thing. It requires somebody else to coordinate and orchestrate across these two entities to then do their thing. And that's what this manages. I'm not going to go into the details of that, the style in which I create these systems of mine that use these principles. I think it's very interesting. I think it's very, very simple to do. If you would want me to make a video on that, please let me know in the comments, and I'll think about making a video where I go much more detail into this and give you some real world examples as well. In the past, I have made a couple of videos. I'll put links to them up here. I think I forget the names, but something to do with implementation guidelines and the facade design pattern or something. I forget the names, but many, many years ago, 7-8 years ago. Nothing much has changed since then. Of course, things have been refined and improved on, but for the most part, they're the same. But just getting back to this, the idea is that you have some other entity, like your team lead is coordinating all the devs on the team to get each of them to do things and then come back, so that the team lead is working across the team to get work done. Right? It's not like he tells you to go to the next person to send your code him there and so on and so forth, and finally just magic happens and it comes back. Imagine the call chain in code, right? A calls, B calls, C calls, D calls, E, like pretty difficult. The other way of doing it is A, team lead, works with B, works with C, works with D, works with E, works with F. A is in control, orchestrating all the different things that can do their work. But A, or this department, as I explained before, is the party, is the thing that handles the coordination across multiple entities rather than the entities themselves being smart. Now, the department, in my case, the manager, doesn't need to maintain state. So the state is given to it. It gets a customer instance that's an immutable DTO. It gets an order instance that's an immutable DTO. It manages these two and creates a customer order by functions that it has, methods, behavior it has. It's not relying on the customer to have behavior or the order to have behavior, right? So that's the essence of this whole thing. This may or may not make sense to some of you listening here. Some of these things are really hard to explain. You got to see it. you got to try it out. Okay, then and compare the two. And you will, of course, if you wrote it one way versus another way, you may not do it the way I'm suggesting. If you would like to do an experiment, get in touch with me. Tell me a simple system that you would like to build the way you build it. Let's say OO style, the OO purist style. And we can work together and then come up with the two different versions of it. If you would like to see, what I would do with that sort of scenario, then, we can do that. We can publish both the versions of the code in GitHub, and I can make another video on this versus that, and maybe other people can join and tell us which one they prefer, right? All right. That brings us to the end of this video. I hope you've enjoyed yourselves. I hope you learned a few things. Please subscribe. Please comment. Please give me a like. And I look forward to seeing you in the next video, which is on the statics. Let's talk. Static classes. Yes, please. And I'll see you next time.